Let us discuss about trig ratios of standard angles. Right? What I want to say is we will look at the ratios of some specific angles which are some standard angles, like we will get the value of sine 30, we will get the value of tan 45, and all these standard angles like 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees. We will find the values of these trig ratios at these standard angles. Okay, so let me first of all revisit some of the geometry. If let us say I talk about a 30, 60, 90 triangle. What do I mean? A triangle has got three angles. Now I am talking about a triangle that has got one of the angles has 30 degrees, one angle has 60 degrees, one angle has 90 degrees. Secondly, we will have a look at 45, 45, 90 triangle. Okay, and look at the ratios of their sides, right? So to find 30, 60, 90 triangle, let me first draw an equilateral triangle. Let us say this is my equilateral triangle A, B, C. So each angle of an equilateral triangle is 60 degrees, right? So this angle is also 60 degrees, but I want you to draw an angular bisector of this angle, right? Dividing it into two equal parts, that is 30 degrees each. So this part is 30 degrees, this part is also 30 degrees. Now what is this angle? This angle is obviously 90 degrees, because in an equilateral triangle the angular bisector is also the altitude. Otherwise you know that this angle is 30, this angle is 60, so the third angle has to be 90 for it to be a triangle, right? You know that sum of internal angles of a triangle is 180 degrees. Alright, I think this much you already know. So let us say that the side of this equilateral triangle is 2a. Okay, I have considered the side to be 2a because I'll need the half of this side. So this portion is a, this portion is also a. Why this is half? Because we know that in an equilateral triangle this is angle bisector, as well as the altitude, as well as the median, right? Otherwise, if some students are uncomfortable, you can notice that all the three angles of these two triangles, this one and this triangle, are equal, and this side here is common to both the triangles, and you can look at these two sides also, right? So we know by side angle side congruence criterion that these two triangles are congruent to each other, hence the corresponding parts are equal. So this part is equal to this part, and both are equal to each other, so half of 2a each. All right, even this much I think you should already know. All right, so now we will focus on this triangle, because this is the triangle that we were looking for, 30, 60, 90 triangle. This angle is 30 degrees, this angle is 60 degrees, this angle is 90 degrees. So let me redraw only this triangle that we are interested in. So this angle is 30 degrees, this angle is 60 degrees, and this angle is 90 degrees. This side length was 2a, this side length was a, right here. So what will be this length here? Now this is a right angle triangle. We can apply Pythagoras theorem to find this length. Let me name the vertices also, a, b, and let us say this is vertex d. This is point D, so this will be vertex D here, right? So if I need to find the length AD, I'll apply Pythagoras theorem. So 2a squared minus a squared and then square root. So this is 4a square minus a square, that is 3a square, and then square root, so root 3a. So this height or this length, side length, is square root 3 into a. Now let us come to the point. So this is a 30, 60, 90 triangle that I was looking for, 30, 60, 90 triangle. And if you notice in a 30, 60, 90 triangle, what are the ratios of sides? Opposite 30 degrees I have got A. Opposite 60 degrees I have got root 3 of A. Root 3 of A. And opposite 90 degrees I have got double of A. Double of A. Right? So in a 30, 60, 90 triangle, the ratios of sides is going to be the same, because I have taken this length, this is general length, this is length A. It can be 1 meter, 2 meter, 3 meter, or any length that you can consider, right? What I mean is this ratio will always be intact in a 30, 60, 90 triangle. For example, if you have got any 30, 60, 90 triangle and you are given a length, let us say this is a triangle that you are given, 30, 60, 90 triangle, and you are given only this length, which is opposite 30 degrees to be 5, let us say, centimeters. Okay, and then what you can say about this length, which is opposite 60 degrees, you can immediately say that this length is 5 root 3 centimeter without any calculations. And what can you say about this length? This length will be double of this length, that is 10 centimeter. This is what you can say directly just by looking at this side length opposite 30 degrees. Okay, so now you can verify also, because if you square it you'll get 25, if you square it you'll get 75, and then you take the square root and you will get 10, which is this length. So in a 30, 60, 90 triangle, the ratio of sides is going to be 1 is to root 3 is to 2, right? Where 1 is opposite 30 degrees, root 3 opposite 60 degrees, and 2 is opposite 90 degrees. So the side opposite to 90 degrees will be double of the side opposite to 30 degrees, and side opposite to 60 degrees will be root 3 times the side opposite to 30 degrees. Just by looking at this ratio you can solve some of the questions. Now the point I was trying to make was, if you want to calculate sine of 30 degrees, now you know by SOHCAHTOA rule that sine is opposite upon hypotenuse. So sine of 30 degrees, what is the side length opposite 30 degrees? It is A. So opposite upon hypotenuse, which is 2A. So I'll write 2A here. So A will get cancelled, hence I'll get sine 30 degrees as 1 by 2, right? So I have found one of the values. Now I can easily find sine of 60 degrees from here, because sine of 60 degree will be opposite, that is root 3A this time, because side length opposite to this 60 degree angles is root 3A, and divided by hypotenuse, which is 2A once again, right? A can be cancelled, so sine of 60 degrees is root 3 by 2. Okay, and then what else? Sine of 90 degrees we will discuss later. Otherwise you can see that sine of 90 degrees is opposite by hypotenuse. In this case opposite and hypotenuse both are same, but leave it for a moment, because I'll discuss 0 degrees and 90 degrees when I draw a unit circle and discuss the angles. I'll discuss it once again. Okay, so let us first of all focus on 30 degrees and 60 degrees. So cos 30 can be obtained by ka, that is adjacent by hypotenuse. So cos 30, what is the side adjacent to 30 degrees? This is root 3a, and hypotenuse is 2a. So root 3a by 2a, root 3a by 2a, that is root 3 by 2. So sine of 60 degrees was root 3 by 2, and cos of 30 degrees is root 3 by 2. Right, so you can also say that sine of 60 degrees is equal to cos of 30 degrees. We will learn about this also. These two angles are also known as complementary angles. So we will discuss about complementary angles in a short while. For now you know the values of sine 30, sine 60, cos 30, and similarly you can find cos 60. What will be cos 60? It will be adjacent. Which is the adjacent side to 60 degrees? This is A, upon hypotenuse, that is 2A. So cos 60 is 1 by 2, which was also the value of sine 30. So sine 30 is equal to cos 60. This 60 and 30 you can notice are complementary angles. So we will learn in a short while that sine theta is equal to cos 90 minus theta, or you can also learn that sine 90 minus theta is equal to cos theta. This can be easily noticed from here. Otherwise also, if I take another triangle, let us say, where I write the angles like this. If this is 90 degrees and this is theta, what will be this angle? In terms of theta, it will be 90 minus theta, right? So if I take this length as A, this length as B, this length let us say as H, so what will be sine theta? Sine theta will be nothing but opposite by hypotenuse, that is A upon H. And what will be cos 90 minus theta? Cos 90 minus theta will be adjacent, that is A upon hypotenuse, that is H. So it will be equal to A upon H. So sine theta is equal to cos 90 minus theta. Similarly, sine 90 minus theta will be equal to opposite, that is B upon this hypotenuse H, right, which is equal to cos theta, because cos theta is what? Adjacent, that is B upon this hypotenuse H. So B upon H also happens to be cos of theta. So we can say that sine 90 minus theta is equal to cos theta. Similarly, we can talk about other angles also, like tan 90 minus theta is cot theta, right? So these conversions can be taken care of. Sine will get converted to cos and cos to sine when you take the complementary angles, and tan will become cot, will get converted to cot, and cot will get converted to tan, and secant will get converted to cosecant, and cosecant to secant. All right, now let us talk about other angles. Sine, cos we have talked. So tan 30, tan is opposite by adjacent. So what is the opposite side here? Opposite 30 degrees, because we are looking for tan 30. Opposite is A, adjacent is root 3A. So A upon root 3A will give you 1 upon root 3. So tan 30 is 1 upon root 3. Tan 60, again opposite upon adjacent. So tan 60, opposite is root 3A and adjacent is A. So root 3A upon A will give you root 3 as value of tan 60 degrees, right? So I think 30, 60, 90 triangle is clear to you. Now let us move to 45, 45, 90 triangle. So 45, 45, 90 triangle, let me create it like this and this. Okay, so if this angle is 90 degrees and this angle is 45 degrees, then this angle has to be 45 degrees. All right, so this is my 45, 45, 90 triangle. If I consider, let us say, this side to be A, what will be this side? This side will also be A. Why? Because these two angles are equal, 45, 45. So their opposite sides will also be equal, because this is an isosceles triangle, right? So side opposite equal angles are also equal. So if this is A, then this will also be A. And what will be this hypotenuse? If you apply Pythagoras theorem, then you will see that this will be root 2 into A, because it will be equal to A squared plus A squared square root, which is 2A squared square root, and hence equal to root 2A. So now we have got a 45, 45, 90 triangle. As you can see, the ratio of sides in this case is, or the absolute value of sides that I've taken this side as A, so the values are A and root 2A. But if you see the ratio of sides are 1 is to 1 is to root 2. These two sides being opposite to 45 degrees and this being opposite 90 degrees. So if you are given a 45, 45, 90 triangle like this, and you know that the value of one of the sides is 1, you will immediately say that this side is also 1 and this side is root 2. So if you are given one of the sides, let us say this side as, let us say 3, you know that this side will also be 3 and this side the hypotenuse will be 3 root 2, to keep this ratio as 1 is to 1 is to root 2. So this is about 45, 45, 90 triangle. Now let us calculate the values of angles like sine 45. What will be sine 45? What will be cos 45? What will be tan 45? Sine 45, so opposite by hypotenuse. So what is the side opposite 45? 3. And what is this side, what is hypotenuse? 3 root 2. Or you look at this general triangle here, this triangle a root 2a. In any case, the value you will get will be the same, but I just want it to be in a generalized manner. So this is 90 degrees, this was a, this was also a, and this was root 2a. And when this ratio of sides is given, you immediately know that the angles are 45, 45, 90. Okay, so now you know sine 45 opposite upon hypotenuse. If you look at this figure, it will be 3 by hypotenuse, that is 3 root 2, 3 upon 3 root 2. Or if you look at this figure, this is also 45, 45, 90. So opposite a and hypotenuse as root 2a. So a upon root 2a. In both the cases, you will get the value 1 by root 2. Okay, in case of cos 45, you will do an adjacent by hypotenuse. So adjacent to 45, you will have a, and hypotenuse you have got root 2a. So a upon root 2a, and hence again 1 by root 2. So you can also say that sine 45 is equal to cos 45 is equal to 1 by root 2. So immediately you know that their ratio sine by cos is equal to tan. So this will be equal to 1. Tan 45 will be equal to 1. Otherwise, you know by TOA that opposite by adjacent. Opposite to 45 is a and adjacent to 45 is also a. So opposite by adjacent being equal will give you a by a will give you equal to value equal to 1. So tan 45 is 1. So now you know sine 45, cos 45, tan 45 also, right? Let us talk about 0 degrees and 90 degrees a little bit, but let me use the circle that we discussed in previous lectures for a moment. Otherwise, you can also talk about it in case of a special triangle, but the triangle will vanish, so you will get confused a little bit. So let me discuss it through the circle, but you can very well understand it through the triangle also. So in the previous lectures, we discussed that if this is x-axis, this is y-axis, this is 0, 0, that origin, and this is the unit circle that we are talking about. So this, the coordinates of this point are 1, 0, coordinates of this point are 0, 1, right? So the angle corresponding to this side, the x-axis, will be 0 degrees because this is 90, right? So we go from here to here to here and ultimately reach at this point, which is 90 degrees, right? So this angle here is 0 degrees. What is angle? In this case, we are looking at the angles with positive direction of x-axis, right? So this is the angle that we are talking about. So when there is a vertical line, that is y-axis, it makes an angle of 90 degrees. All right, so x-axis makes 0 degree with itself. So this line corresponds to 0 degrees, and we know what are the coordinates of this point, 1, 0, and we also know that every point corresponds to, let us see, if this angle is theta, then this point has got coordinates cos theta, sine theta. We have discussed about it in previous lectures, right? So what will be the coordinates of this point in terms of cos and sine? It will be equal to cos 0 degrees, sine 0 degrees, right? But we know that the coordinates of this point are 1 and 0. So cos 0 is nothing but 1 and sine 0 is nothing but 0. All right, and what about tan? What about tan? Tan is nothing but sine upon cos, right? Tan theta is nothing but sine theta upon cos theta. So sine theta being 0 and cos theta being 1, tan theta is also 0 at 0 degrees if theta is 0, right? So sine 0 degrees is 0, cos 0 degrees is 1, and tan 0 degrees is 0, right? Now let us talk about 90 degrees, that is this angle here, this angle. So the coordinates of this point in terms of cos and sine are cos 90 degrees comma sine 90 degrees. But we know that the coordinates of this point are 0 comma 1. So cos 90 is nothing but 0, sine 90 is 1. So I can write cos 90 is 0, sine 90 is equal to 1. Okay. For now, for this lecture, like this is going for class 10th. So first of all, I will talk about angles between 0 and 90, and then we will extend this discussion to other angles also, like the big angles, allied angles, 180 plus theta, and then 720 plus theta, or any angle that you want, right? So we will talk about those angles also because in trigonometry we are not limited to triangle only. We will go beyond that in terms of angles. So for now, let us focus on the standard angles, values of standard angles, because that was the topic for this lecture. So what will be value of tan 90? Tan 90 being sine 90 upon cos 90 will become 1 upon 0, but 1 upon 0 is not defined in, right? It is not defined. So value of tan 90 degrees is not defined, or some of the books will write this value as infinity, because cos 90 is 0, so the value of this tan 90 will be very large, very large, right? So it will be infinity. Or if you want to say it correctly, if you want to be very correct mathematically, you will say not defined, right? At the level of your class, 10th class, it may be written infinity also. Okay, so now you know values of standard angles. So let us jot down these values at one place and make a little table to memorize these values. Okay, so we will talk about values at these angles. I will not give you any shortcut to memorize, but whatever we have learned so far, we will just write these at one place. So I'll write 0 degrees, 30 degrees, 45 degrees, 60 degrees, and then 90 degrees. Okay, here I'll write the trig ratios: sine, cos, tan. Rest of the values are very simple because those values are reciprocals of these three ratios, right? We will write them separately. So sine 0 degree was 0, sine 30 was 1 by 2, sine 45 was 1 by root 2, sine 60 was root 3 by 2, and sine 90 was 1. So cos 0 was 1, cos 30 was root 3 by 2, and cos 45 is same as sine 45. Cos 60 is 1 by 2, and cos 90 is 0. So if you notice, sine values are 0, 1 by 2, 1 by root 2, root 3 by 2, 1, and cos values are 1, root 3 by 2, 1 by root 2, 1 by 2, 0. Right? We have just flipped these values of sine, right? Right? It starts with 0, it ends with 0, then there is 1 by 2, there is 1 by 2, right? So this may help you to memorize these values. Tan 0 was 0 because sine was 0, tan 30 was 1 by root 3, tan 45 was 1, and tan 60 was root 3, and tan 90 is not defined, or in some of the books you will write infinity, not defined. Okay. Now the other ratios are nothing but these can be written very simply because those are reciprocals of these values. Sine, cos, tan, then write cot, sec, cosec. Okay, so cot is reciprocal of tan. So 0 at 0 degrees, if tan is 0, then the reciprocal, that is 1 by 0, is of course not defined, right? Reciprocal of 1 by root 3 is root 3. Reciprocal of 1 is still 1. 1 by reciprocal of root 3 is 1 by root 3. And this at cot 90, if you notice, cot 90 is what? It is equal to cos 90 by sin 90. Now sin 90 is 1 and cos 90 is 0. So it will be 0 by 1, which is very well defined and is equal to 0. Okay. Similarly, you can write values of secant. If you notice tan and cot also, these are just flipped values, right? So if you know the similar manner, you can write values of secant by taking the reciprocals of cos values. So it will be 1, 2 by root 3, root 2, 2, and this is not defined. And in the end, cosecant is reciprocal of sine values, so it will be 1 by 0, so not defined. Or let me write it in other way. I'll write it from secant perspective, right? We know that the values of secant are 1, 2 by root 3, root 2, 2 not defined. So I'll start with this not defined, then I'll write 2, okay, then I'll write root 2, and then I'll write 2 by root 3, and then in the end 1. Now you can verify it also, because reciprocal of 0 is not defined. 1 by 2, reciprocal is 2. 1 by root 2, reciprocal is root 2. 2 root 3 by 2, 2 by root 3, 1, reciprocal is 1. So this is the table of values of some standard trig values, some trig ratios at some standard angles. This was the purpose of this lecture. Now in the next lectures we will discuss about some other angles also, right? Very, very large angles. And okay, so this was about this lecture.